Here we want to rewrite the sum of n equals 1 to infinity of 1 over 3 to the n in part A with the starting index of n equals 0. So the original starting index is n equals 1. Let's make sure we really understand what's happening here. So let's start by writing out a few terms in the series. So let's start by substituting in 1. So we'd get 1 over 3 to the first, and then plus 1 over 3 squared, plus 1 over 3 cubed, and so on. So if we want to write our summation notation with a starting index of 0 instead of 1 and still arrive at the exact same series, let's think about how we would have to manipulate the variable n in our general term. So right now it's 3 to the n. And so we know we can't leave it like that, because if we substitute in 0, we'd get 3 to the 0, which is 1, and the first term needs to be 1/3. So we need the first exponent of 3 to be a 1, not a 0. So what I'm going to do to the n is add a 1, 3 to the n plus 1. And so now we can check to make sure this works. If I substitute in 0 into n, I have 1 over 3 to the first. And if I plug in 1 next, 1 plus 1 is 2, so I'm going to get plus 1 over 3 squared. Then I'd plug in 2, 2 plus 1 is 3, 1 over 3 cubed, and so on. So this is rewriting my summation notation to have a different starting index, a starting index of 0. Now, let's say we wanted to have the exact same series with a starting index of n equals 2. So we're going to have the sum of n equals 2 to infinity. Let's go ahead and leave it as the original for a second and see what would happen. So if I leave it as the original general term, 1 over 3 to the n, I start with 2, my first term is going to be 1 over 3 squared, and I want it to be 1 over 3 to the first. So this time I'm going to have to subtract 1. This time I'm going to have to subtract 1. And so if we do that, we can check to make sure it works. So we have 3 to the 2 minus 1, that's 1, so 1 over 3 to the first, and then 1 over 3 to the next one I'd plug in is 3, 3 minus 1 is 2, 3 squared, and I'll leave it there, and so on. So this is rewriting my infinite series with the starting index of n equals 2. Let's try to generally look at sort of the pattern. So when I started with n equals 1, to move to an index back 1, I needed to add 1 to the variable n. If I wanted to move the index up 1, so to go from n equals 1 to n equals 2, I needed to subtract 1 from that variable n. The way we can think of this and connect it to something in our previous knowledge is when we think about shifting a function to the left or to the right. All right, let's try this again. Let's rewrite the sum of n equals 0 to infinity. All right, let's try this again. Let's rewrite the sum of n equals 0 to infinity of 2n plus 3 over n factorial. So first, with a starting index of n equals 1. So let's look at what our original starting index is, n equals 0, and I want to move it up 1 to n equals 1. So how that's going to affect the n's, because there are 2 this time, in the general term, is I'm going to have to make each of these n minus 1. So let's go ahead and do that. So we have the sum of n equals 1 to infinity of 2 times n minus 1 plus 3 over n minus 1 factorial. And then let's check it out. Let's make sure that this actually works. So if we start with an index of 0, 2 times 0 plus 3, that's 3. And then 0 factorial by definition is 1. So my first term is 1. Then if I plug in 1, 2 times 1 plus 3 is 5. So we have 5 over 1 factorial is 1. And let's try one more. If I plug in 2, 2 times 2 plus 3 is 7. And then over 2 factorial is just 2. And so on. So let's make sure that this yields the same collection of terms. So if I start with n equals 1, I'm going to get 2 times 1 minus 1, that's 0, so that's gone. So I just have a 3 in the numerator. And then 1 minus 1 is 0, and we said 0 factorial is 1. And maybe we'll just try one more. If I plug in 2, 2 minus 1, that's 1. 1 times 2 plus 3, that's 5. And then I have 2 minus 1, 1 factorial is 1. So we can see that this is going to give us the same infinite series. Now we can rewrite this a little bit nicer. So we could write the sum of n equals 1 to infinity. I can distribute the 2. So 2n minus 2 plus 3, that's going to be 2n plus 1. And then we will leave it as just n minus 1 factorial. I can't really do anything with that. So here we have rewriting this with a starting index of 1. So we started with n equals 0. To go to n equals 1, one higher of a starting index, I needed to subtract 1 from the n's. Now, if I want to move up to a starting index of 2, hopefully we could figure out that if I start with n equals 2, now in place of each n in the general term, I have to replace it with n minus 2. So 2 times the quantity n minus 2 plus 3 over n minus 2 factorial. And I'm not going to show the work to check it. This is correct. We could simplify the numerator a little bit further, and we'll have n equals 2 to infinity. We have 2n minus 4 plus 3, so 2n minus 1 over n minus 2 factorial.